some questions like is there any difficulty that you have faced in the previous class, or is there any question that you want to ask me regarding the previous lecture? Until now, all my previous lecture is okay for you. Is there any question that you want to ask me regarding previous lecture? Those who are present in my last class, I'm asking them. Anyone has any question regarding my previous lectures? Okay, your silence, I think I will assume that you don't have any question, because in the chat box you have also written that there is no question. Okay, so let me continue with the today's discussion. I hope whatever I discussed in my previous class, all are very much understood by you. So I think we can continue with today's discussion. So let me before starting the discussion, let me share the screen, and let me just revise the last class discussions once. That in the last class I have discussed about the basic definition of cloud computing, what is cloud computing and how we can define cloud computing. And then I will show you the discussion about why we use cloud computing. And I have shown different real life scenario or real life case studies, based on which I have shown that what are the benefits or what are the aim of using this cloud computing platform, right? Then I also discuss about most of the essential characteristics of cloud computing, like resource pooling, elasticity. I discuss about why cloud computing is called elastic computing. That thing I discussed in my last class. Shared infrastructure, I discuss about the cost effective and on demand self service. These things I discussed in my last class. And maintenance, and I discussed a little bit about maintenance and security in my last class. So only 2 points which I left to discuss as one of the essential characteristics of cloud computing. One is centralized and homogeneous system. Cloud computing is also called centralized and homogeneous system. And the second one is virtualization. Okay, so these two things I give you, I want to discuss in my class, in this class. And I have given some flavor of virtualization as well in this class, but virtualization is a separate topic. I actually mentioned a separate lecture for this topic. It is a huge topic and a very important topic in cloud computing. But today in my class, I'm just giving the introduction of virtualization. Okay, so these are the things which I discussed. So today we will start our lecture, our discussion about the different computing systems, or the differences between cloud computing and its predecessor computing system. Okay, these are the computing system which evolved before cloud computing. So that's why those are called predecessor cloud computing system, or you can say cloud computing is a successor of this system. So two systems we generally discuss with cloud computing. We generally want to discuss the differences between them. One system is grid computing, another one is utility computing. Okay, how cloud computing differs from grid computing and utility computing. So before I'm starting a discussion of grid computing versus cloud computing, I want to tell you that cloud computing concept did not evolve at once. Okay, it actually a result of long years of research on this computing, like on this grid computing, over the distributed computing, over a long research of utility computing. And cloud computing is just nothing but a result of the combination of those research on this predecessor computing, like grid computing, uh, virtualization, utility computing, and distributed computing. Okay, so this is actually a is extension and very you can say very modified computing system compared to its predecessor computing. So what is the modification, what is the advantage, and what is the differences between them, what is the disadvantage of cloud computing uh, uh, over grid computing, that we will discuss. So first I will want to discuss what is grid, what is computer grid, and what is grid computing. So this grid computing, utility computing, all are part of distributed computing. So grid computing is actually a distributed system consisting of a large number of loosely coupled, heterogeneous, and geographically dispersed system in different administrative domain. The vision of the grid movement was to give a user the illusion of a very large virtual supercomputer, right? So these are the 4 points in this definition of grid computing. There are 4 points that you need to understand, or you can say need to remember, that actually makes the difference between cloud computing and grid computing. The first point is that loosely coupled. Remember one thing: cloud, grid, this grid computing, utility computing, all are distributed system. So grid computing, the first point I need to remember, it is loosely coupled. So let me just, I think most of you have some idea regarding tightly coupled and loosely coupled system, because you have some idea regarding distributed system. So just let me remind you some definition behind loosely coupled and tightly coupled. Tightly coupled system is such a system where both are distributed system. Tightly coupled and loosely coupled, both are different types of distributed system. Okay, so distributed system means under a common scenario, under a common administrative domain, there are multiple systems which are distributed and which are geographically separated, geographically distinct from each other. Okay, which are situated in a distance of geographically boundary. So the thing is that in a case of tightly coupled system, all the systems, distributed system, are sharing the same processor, are sharing the same memory, and sharing the same networking apparatus or networking system. That means a tightly coupled system is totally tightly coupled with each other based on the common sharing of the resources, right? That is a tightly coupled system. Whereas in a loosely coupled system, just opposite of it, each and every system in loosely coupled system, distributed system, each and every system must have its own local memory, its own local database, local storage devices, its own local processor. Okay, so it can use its own local processor to process the data. It can use its own local storage devices to store the data. It doesn't depend on the centralized, or you can say the centralized resource system, unlike tightly coupled system. So computer grid is a loosely coupled system, whereas cloud computing is a tightly coupled system. Please remember, cloud computing is a tightly coupled system, because all the data, all the resources in case of cloud computing are generally centralized in fashion. That means there is a central data warehouse. So suppose there is a cloud computing platform is working in India, suppose, right? So so they may have one centralized data warehouse, or a data center, where all the storage devices, hardware storage devices, network devices, all the processor devices, all are stored into a single region or single location. That centralized data warehouse may be a very big one. Okay, so it is a single region. And cloud computing virtual machines which are actually working under the platform of a cloud computing, they are actually sharing the resources from that single centralized data warehouses. Okay, so if Amazon AWS are using throughout the India, then there must be one central data warehouse or the data storage system where all the resources are stored, physically are stored. Hardware resources, I'm talking about hardware resources, those are physically stored. And by the help of virtual machines or cloud platform virtualization concepts, any user or any organization can use the cloud platform of Amazon AWS throughout the India. Okay, so this is the main concept of cloud computing, and difference between cloud computing and grid computing in case of loosely coupled, tightly coupled system, and centralized, decentralized system. So cloud computing is a centralized system, whereas grid computing is a decentralized system. In case of grid computing, there are different areas, different warehouses where the data has been stored, or you can say where the resources are stored. Okay, unlike cloud computing. So this is the difference, decentralized and centralized, in between cloud computing and grid computing. I think it is clear to you, right? Now the second thing is that, which is like nothing but an extension concept of this centralized and decentralized. That is the last one, single and different administrative domain. Okay, in the definition, it also represents the definition of grid computing in different administrative domain. So grid computing is actually controlled in a different administrative domain, whereas cloud computing has been controlled by a single administrative domain. So you can understand, if it is a centralized, if a cloud company is depends on a centralized data center or centralized epicenter of resources, so there must be a centralized team or centralized service provider which actually maintaining or doing some taking some administrative decision based on that particular centralized resources. Okay, centralized resource center, centralized data warehouse center. So that's why there is a single administrative domain which actually monitoring or controlling that centralized data warehouse maintained by a particular cloud. So obviously Amazon AWS has some centralized data warehouse in India. In the same way, Microsoft has a centralized data warehouse for his own platform, own cloud platform. In the same way, the the Google also has a centralized database area or data warehouse area for its resources for its own cloud platform, and all this individual company has their own service provider management team, and those management team are actually handling or monitoring those resources or controlling those centralized resources by the help of single administrative domain. But in case of grid computing, these administrative domain are different. Why different? Because the grid in grid computing is loosely coupled and it is actually decentralized. Decentralized means the resources has been spreaded throughout the country in different regions, different warehouses are there. So there must be different administrative domain to control those different warehouses, different service provider team to control those different warehouses. Okay, so that's why it is called different. It is under the grid computing is under different administrative domain, right? So I think this conception is clear. And the last difference between cloud computing and grid computing is heterogeneous and homogeneous. This is also a very important difference. Whereas grid computing consists of homogeneous type of systems. Okay, if it is a virtual system, then virtual systems, and cloud computing consists of homogeneous type of systems. Okay, so what is the advantage disadvantage? First let me clear you what is homogeneous, what is heterogeneous. Homogeneous means the system with the similar type of characteristics, similar type of architecture, similar type of formation is there. So it is easier for a centralized team to control or maintenance in terms of maintenance those homogeneous type of system, because though all the system has a similar sort of architecture, so it is easier, it is much easier for a centralized a cloud service provider team to maintain that homogeneous system. Whereas in case of heterogeneous system, it is difficult for the service provider team to maintain heterogeneous system. Why heterogeneous? Because different system has different sort of architecture, different sort of behavior, different sort of operating system. Everything is different. So there is no similarity between the among the systems in the grid computing. So grid computing generally follows heterogeneous type of architecture or heterogeneous type of system architecture, whereas cloud computing follows homogeneous type of system architecture. Okay, so these are the main four differences between cloud and grid. I think your conception will be clear. Is there any questions about the difference between cloud computing and grid computing? Do you have any questions? These questions frequently come. Okay, the difference between its predecessor computing. So you have to know the answers. Is anyone has any questions regarding the difference between cloud computing and grid computing? Any doubt? You won't understand anything? Hello? Anyone has any question?
No, sir.
Okay, so we will move towards the next type of predecessor computing and show the difference between cloud computing and that computing, which is known as utility computing. So before I'm showing you the differences between cloud computing and utility computing, I want to tell you what is utility computing. This utility computing I already discussed in my last lecture. If you remember, I told that cloud computing inspired from that pay as you go model. Pay as you go model means whatever how much you are using in cloud platform, you have to pay accordingly. Okay, only that amount of use. If you are increasing your use, you have to increase your pay, increase your subscription price, or if you're decreasing your use of resources, you have to also give a less subscription price. So how much you will use, you will have to pay. So utility computing, the basic example, a basic uses of utility computing is electricity metering. Okay, electricity billing at our home purpose. Okay, so electricity billing, as all of you know, that how much electricity, how much unit you will consume at your home, you will have to pay only for that amount of charge. Okay, you don't need to pay any extra charge. According to the consumption, you will have to pay. Now utility computing, now we can say, sir, then cloud computing, utility computing are two features are very much similar. Then where utility computing is using and where cloud computing is using. Now utility computing is suitable for the small businesses where small scale of usage are there. Okay, it is a good resource for small businesses, but for the large businesses where the infrastructure is one of the issue. Large businesses means where the infrastructure, large business means it may be geographically big region. Okay, geographically separated. So from you are connecting by the cloud computing, you are connecting from one country to another country servicing. Okay, so for this sort of large computing or large scale businesses, utility computing is not suitable. Okay, so utility computing is suitable for the businesses like electricity billing. It is suitable for the business like customer relationship management. If you are talking from the software point of view, then CRM is such a software, customer relationship management, which actually uses utility, the concept of utility computing at the small businesses, okay, where there is a limited budget, right? So without investing heavily on the infrastructure, for those cases utility computing performs well. Okay, now for the big scenario, that means where you have to invest more money in the infrastructure, for those big cases, for big scale of businesses, big scale of usage, cloud computing is more suitable than utility computing, right? So let me discuss the differences between cloud and utility. So the first is actually the similarities, not the differences, because both are based on the pay as you go model. So how much you will use, you will have to pay accordingly. Okay, so both utility computing and cloud computing. Now second difference is that utility computing users want to be in control of the geographical location of the infrastructure, whereas cloud computing provider is in complete control of cloud computing service infrastructure. Actually, utility computing generally using just like the grid computing system, it is a dispersed system. Okay, dispersed system means it is actually a uh, it is actually spread in different region, and it has been controlled by different administrative domain. So I already told, if it is a controlled by different administrative domain, so then there is some relationship gap, or there is some communication gap between those different administrative domain. There may some communication gap, so it will be difficult to manage all the different administrative domain under the same umbrella. So that's why utility computing is good for the small businesses. Okay, because for small businesses has a small exposure, so there is a small number of administrative domain which may be controlled, which can be controlled more easily. But in case of cloud, it is a centralized model. Centralized model means there is only one center of the data warehouses, or you can say the resource warehouses, or the pooling of resources, where the cloud service provider, based on a request of the customer, the cloud service provider pool a certain number of resources and give those resources to the customer. And if the customer doesn't want to use those resources further, it actually pull back those resources and return back those resources into the resource pool of the centralized data center. So it is the cloud, in case of cloud computing, due to a centralized infrastructure, it is well maintained and well controlled by the service provider team. This is the second difference. Now third difference is that utility company is more favorable when performance and selection infrastructure is critical. The same thing, more or less the same thing. That means in case of infrastructure, if it is a big infrastructure, okay, or large scale infrastructure, then utility computing is not suitable. But cloud computing is suitable for the large scale infrastructure. I already told you the reason of it. Okay, now the next difference is that utility company is good choice for less resource demanding. Obviously, if it is a small business, scale business, there is a demand of resources also less. Okay, so for this less resource demanding, in that case utility computing is good. But you have to remember, both utility computing and cloud computing has that concept of on demand self service. Okay, pay as you go model. Okay, both are the similar in these features, pay as you go and cloud services, and they are dissimilar in the features like single administrative domain, distributed administrative domain. Like cloud computing focuses on large scale industry, whereas the utility computing focuses on small scale industries. Okay, and cloud computing focuses on a large infrastructure. It can be well maintained and well controlled in a large infrastructure, whereas utility computing cannot be suitable for the large infrastructure. Okay, and utility computing refers to the business model, whereas cloud computing refers to the IT industry. So mainly cloud computing, as all of you know, that cloud computing is a part of the IT industry and IT architecture. It is hugely or heavily used, but in utility company, it is mainly used for the other type of business model, like electricity business model or customer relationship model. This sort of model, it is not suitable for IT industry. Utility computing. These are the main difference between utility and cloud computing. So is there anyone has any doubt about the difference between utility computing and cloud computing? Any point you didn't understand what I discussed? Give me your feedback. Is there any doubt regarding utility computing and cloud computing, the differences?
So how utility computing is a good choice for less
Yes.
resource demanding.
Yes, can you
And
repeat?
the the fourth point in this table.
First point, right. What do you want
Fourth
to?
point, sir.
This one, right?
No, sir. Second last, sir. Second last.
Oh, the second last, this one.
So can you explain this part?
Huh. It's a very easy thing. Utility computing is a good choice for less resource demanding, and cloud computing is a good choice for high resource demanding. So I have told multiple times the same thing, that utility computing is suitable for the small scale businesses. Okay, which I already discussed in my previous slide. It is suitable for the small scale usage or small scale businesses like electricity metering at home or customer relationship management. So obviously,
Hmm.
if
Yes,
it
sir.
is, if it is suitable for the small scale businesses, obviously it requires a less number of resource demanding. Okay, it demands less
Yes,
number
sir.
of resources. So that's why the point has been given, the utility company is a good choice for less number of resources, on demand resources, whereas cloud computing is suitable for large business, large scale business. So obviously in large scale business has a large demand of high resources, so that's why cloud computing is suitable for the high resource demanding. Clear?
Okay, sir.
Okay,
Yes, sir.
anyone? Okay, thank you. Anyone else? Any question, any doubt? Is there anyone, any question, any doubt? Okay, I assume that there is no doubt. So we will move forward. So next topic that I am going to discuss, the actual cloud architecture. Okay, this is one of the most important topic in cloud computing system, whereas this cloud architecture has been followed by all sort of cloud computing platform. That means this is a common architecture or generalized architecture which is followed by Amazon AWS as well as Google Cloud or Microsoft Azure Cloud or IBM Cloud. Any one of the cloud you can pick up, and they will follow all, they will follow this generalized cloud architecture, right? Now this cloud computing architecture, cloud architecture is divided into four groups or classified into four groups. The first group is the delivery models. This architecture is very, very important. Lots of questions are coming from this architecture. Okay, especially the first two, delivery models and this deployment models. You can assume that question you will already receive from these models. Okay, so delivery models is the first kind of classification of cloud architecture. Where within the delivery models, there are three majorly classified models. One is SAS, software as a service. Second model is PaaS, platform as a service. Third one is third delivery model is infrastructure as a service, ES. Okay, SAS, PaaS, ES. Apart from this, there are some other modules like data as a service, DAS, then compliance as a service, CAS. Okay, but those are the actually the extension of this module. Main models is this, for these three are the main models. Okay, where the entire cloud architecture is depends and is delivered based on these three models. Okay, how it is delivered. So I am going to discuss this delivery model each and individually with some relative practical examples. Okay, now go to the next one, is a deployment model. Deployment model is actually differs how many different type of cloud computing models are there. Okay, different type of clouds are there. So where you are deploying your applications. Okay, you are deploying your, that's why it's called deployment model, where you deploy your application. Deploy means actually you are executing your application or you are executing the application as a package. Okay, and the customer can use that package after you are deploying that execution, after some time of deploying the execution, the customer can use that package as a from the user end through its GUI, and they can give you the feedback how your application software is working. Okay, that means you actually deploying you may deploying your beta version of your software into the model into the cloud platform, and the customers can check that application. You also may be your own customer. Okay, you can also perform the role of your own customer, no problem. That is also pop, or your colleague can perform as the customer of your model, and they can give you the feedback how your software is deploying or working, right? So based on these deployment models, cloud can be our four types. One is private cloud, second one is community cloud, third one is public cloud, and fourth one is hybrid cloud. I will discuss these four clouds individually. Okay, now the last two, these two are nothing going to discuss, because all these things I have already discussed, like how many resources are there in cloud architecture. Resources play the very vital role there, and resources generally focused on two types. In my last lecture I discussed there are two types of resources: software resources and hardware resources. So okay, if this meeting link will expire, everyone please click on the same link to join in the next session. Okay, so resources in this box there are only mentioned the hardware resources like compute means your processor, then storage servers are there as a hardware resources, network servers are there as a hardware resources, Virtualization is also there as a resources, hardware resources. No, sorry, virtualization is software resources. Whereas these are the hardware resources. Okay, your storage servers, network servers, compute servers. I already show some demo of these hardware resources in Amazon AWS platform in the last class. Okay. Now, the fourth type of classification, or you can say the type is from cloud architecture is attributes. Okay, what are the attributes are there of cloud architecture? So pay per usage, okay, which I already discussed multiple times. Utility computing, which I discussed already, and elasticity. Cloud computing is also called elastic computing, and I discussed why it is called elastic computing due to the flexibility or a illusion of a infinite number of scaling of resources. That's why it is called elastic computing. Okay. So these are the main components of a cloud architecture. Now I'm going to discuss with the first component. I will start the discussion about the first component, delivery models, SAS, PaaS, and yes. Okay. So this is one of the things. The cloud computing simple definition is actually a combination of these components: SAS, PaaS, yes. Data as a service you can give is optional. You may give, you may not give, doesn't matter. But these three components are mandatory, based on which collaboratively it will form the cloud computing platforms. Okay. Now these three model can be organized. If you will organize these three model as a pyramidically, this is actually a delivery model scenario. If you organize in a pyramidal structure, then the first and the top layer is called software application layer, which represents SaaS model, software as a service. Okay. The middle layer is represent a platform, so it will represent the platform as a service, PaaS layer. And the last one, it deals with the infrastructure or physical resources, so it will represent the last layer, infrastructure as a service. Yes. Okay. SAS, PaaS, and yes. So we will go to this lecture and try to understand. Everyone listen very carefully. This is a very interesting and very important as well, because if you understand these things, I am giving some practical example to give you an understanding on SAS, PaaS, yes, because in the book it has been written. In lot of books you will get the SAS, PaaS, yes, but its language is very tough. In cloud computing, the language of the books are very tough. So if you don't attend my classes, or if you don't listen my lectures, then it will be difficult for you to crack those words. Okay, to understand those words. So that's why I'm suggesting you to attend the classes, and what I am going to tell you, please listen. Okay. So suppose I'm giving a practical scenario. Okay, suppose you are throwing a birthday party. Everyone please listen very carefully. I'm showing you the practical scenario with respect to SAS, PaaS, yes. Suppose you are throwing a birthday party, okay, among four friends. Okay, you have four best friends, best buddies in your college. Now you are throwing a birthday party, and you are throwing that birthday party at your new home. So you have purchased a new home in a complex, in a big complex. Okay, flat complex, whatever you say, apartment complex. So in that complex, you are throwing you have purchased a new home or new flat. So that's why you have thrown a party as well as your birthday party, and you want to share the birthday party, or you want to entertain the birthday party with your four friends, right? Now you are planning to serve them pizza as one of the cookies, as one of the food of your birthday party to your friends who are the invited people, like your friends. Now suppose you have uh, that flat is actually very new one, so you don't have any utensils, any gas burners, any cylinder, anything else, okay, installed in the flat till now. Okay, this is a very new flat, so it is all alone. So you actually cook the pizza for the four friends from your old home, and you are carrying those pizza in a new flat, and where you actually entertain, or you actually join for the party. Okay. Now the thing is that, suppose those four friends suddenly arrived with their own family members. They have carried their children, they have carried their parents, they have carried their wife. So all total, instead of 4 people, now 20 people has suddenly arrived in your party. Now you will face a problem regarding the food, because you have cooked pizzas only for 4 people. You didn't cook pizza for all the 20 people. Now how we are going to solve this problem, and how we can compare of solving this problem in terms of these three platforms, SAS, PaaS, yes. Try to understand. The first solution, what you will do, the easiest solution is that you will have to call the nearest pizza center. That is, it may be Domino's or it may be Pizza Hut. for the pizza, and you can put an order through their software, and they will deliver the order after half an hour, right? So this sort of scenario handling is called software as a service, SAS. That means, as software as a service in terms of cloud computing platform, it will be seen from the customer point of view. The software as a service you will see from the customer point of view. That means the customer is actually directly accessing the softwares or application softwares at the upper layer. That's why in the pyramid, the software as a service at the upper layer of the pyramid. It contains in the upper layer of the pyramid. So it actually uses the software to communicate with the underlying hardware or to communicate with the underlying applications. Okay, so this is one of the thing that by which you can solve the problem. Now the second way how we are going to solve the problem. Now in a flat there is a neighbors. Okay, so there is a neighbor who who already you know him previously. So you are going to him or her and rent his gas burner as well as his cylinder, okay, to cook the pizza at your own flat, new flat, for all the 20 people, to serve the dish for all the 20 people. So that neighbor actually give you the give you his gas burner and cylinder with a hourly rating basis. Okay, pay per hour in that basis. So suppose you are taking the gas burner and cylinder for 2 hours, and each hour you will have to pay 200 rupees. So total 400 rupees you have to pay to the neighbors for their renting gas burner and cylinder. Okay, so this is one of the way you can handle the problem of shortage of pizza for 20 people. Now how you can compare this with a platform as a service? So platform as a service means you here you are cooking, instead of ordering the pizza directly from the Domino's, you are cooking the pizza in your own platform at your home. Okay, at your new flat. So here is the platform is actually gas burner and cylinder where you can cook your pizza. Okay, this is a small scale platform, small scale. Okay, so how we can compare this thing with cloud computing concept? Suppose you want to this SAS is actually from the developer point of view. Please remember, SAS is actually represented from the customer point of view, who are directly using the application software, whereas PaaS is related from the developer point of view. Okay, developer, that means who actually developing the code, okay, or implementing the code. And developer generally implements his or her code in different platforms, especially in different frameworks. Okay, in computing term we can use frameworks. Like you are using .NET framework to develop your code. You are a developer, you are using .NET framework and PaaS platform to develop your code. Okay, or you are using Java framework or Python framework. I already told in the last class, cloud computing platform generally prefer to use object-oriented framework because of platform independency feature. Okay, that I already discussed in the last class, why they are using platform independent features. Okay, why they prefer to use object-oriented framework. So this sort of framework, as a developer point of view, we can use the PaaS platform as a service. Not only that, PaaS also includes your system software. That means you are not only developing the framework, but also you are deploying the framework on a operating system. So that operating system may be a Unix operating system, maybe a Mac OS, maybe Solaris. So those operating system is not possible for you to save, to store or install each and every operating system in your home laptop or home machines, because all these operating systems are chargeable, subscription based. So you are renting those operating system from any one of the cloud service provider. It may be Amazon, Azure, or IBM, and using its PaaS platform or operating system virtual operating system to deploy your code. Okay, to run to execute your code, or you can say to develop your code, right? Now the last one is the underlying layer, which is called infrastructure as a service. So instead of so in this pizza scenario, how it will define? So instead of doing opting these two options, you are directly going to the housing committee chairman of your complex, and you are just renting the entire community hall. So in the entire community hall, you have already get all the gas burners, even the chef or delivery boys,